Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Docker Jr., your math tutor and an instructor of mathematics at the University of Liberia. So in my today's lesson, I will be continuing on differential equations. And like we started in previous lessons with variable separable method. So we want to look at additional problems on a reducible to variable separable method. So we said in case we have a differential equation of this form, dy by dx is equals to ax plus by plus c. So if we have a differential equation that comprises of this kind of function, what we need to do is to substitute this particular function with some other variable, like a single variable, and then we differentiate both sides of that new equation. And when we replace dy by dx and we replace this expression, we can now have a differential equation that has been reduced to a variable separable method. So we want to solve an additional problem under this topic. So the question says x plus 2y times dx minus dy equals to dx plus dy. So for this problem, the first thing we need to do, we need to put it in this form. Dy by dx is equal to some function. So we need to solve for dy by dx. So how do we go about solving for dy by dx? We can multiply this first parenthesis with the second and group all of the terms with dx on one side of the equation and the terms with dy on the other side of the equation. So let's go ahead. We have x times dx is x dx. X times dy is x dy. 2y times dx is 2y dx. And 2y times dy is negative 2y dy. All equals dx plus dy. So what next we need to do? We group all of the terms with dy on one side of the equation. These are the terms with dy. So we group them on the left-hand side since we want to have dy by dx. So group the terms on this side. So it's minus x dy minus 2y dy. And then we send this one across, it becomes minus dy. All equals dx. So we send this one across, it becomes minus x dx. And this becomes minus 2y dx. So because of the too many negatives that we are experiencing, we can multiply all sides by minus 1. So the result now will be if each term is being multiplied by a negative, we're going to have x dy plus 2y dy plus dy equals negative dx plus x dx plus 2y dx. So the next thing we need to do is to factor out dy and also factor out dx, because dy is in each term and dx is also in each term. So what is left is x. What is left here is 2y, and this is plus 1. The coefficient here is just 1. What is left here is minus 1. Coefficient is 1 plus x plus 2y. Now, since we want to have dy by dx, we have to divide both sides by dx to get rid of the dx from that side. So dx cancel. So we also don't need this expression right here. So we divide both sides by x plus, this is 2y, plus 2y plus 1. And also x plus 2y plus 1. So this and this cancel. So now we have dy by dx will just be equal to, so we can rewrite this x plus 2y minus 1 all over x plus 2y plus 1. So this is the new differential equation. But again, we cannot separate the variables. If we cross multiply dy by x plus 2y plus 1, dx by x plus 2y minus 1, if we cross multiply, we cannot separate all of the x and all of the y expressions. So we bring in this substitution. But x plus 2y minus 1, we cannot substitute the entire thing because we have minus 1 here and we have plus 1 down here. So our major concern is to ensure that the two variables become one variable. So these two variables, we want to reduce it to a single variable. So our substitution will just be x plus 2y. So now we can do the substitution here. We say let some variable u equals to x plus 2y. So now that we have a new equation that brought in a new variable or a new function as well. So we have two functions now, which is u and y. So whenever you are differentiating a function, you attach, like you're differentiating u, you attach some derivative notation. That is, for u, you attach du by dx, and for dy, you attach dy by dx. Now, the x is the variable of differentiation, the independent variable within the function. So we have du by dx equals derivative of x is 1 plus this becomes 2 dy by dx. What's the next objective is for us to solve for dy by dx. So we can send this one across. It becomes du all over dx minus 1 equals to 2 dy by dx. Lastly, we can ensure that this dy by dx has a coefficient of 1. So we need to get rid of this 2. So since 2 is in the numerator, we can multiply both sides by 1 over 2. So 1 over 2 times the left-hand side, which is du by dx minus 1, equals dy by dx. So now let's replace. So wheresoever we see dy by dx, we're going to write 1 over 2 times du by dx minus 1. And then wheresoever we see x plus 2y, we're just going to write u. So it's u minus 1 all over u plus 1. Now our objective is to ensure that we separate all of the expressions with x on one side of the equation and the expressions with y on the other side of the equation. So to do that, we can multiply this 1 over 2 by each term in here. So we can say 1 over 2 du by dx. 1 over 2 times 1 is 1 over 2, or equals to u minus 1 all over u plus 1. Next, we send this minus 1 over 2 on the right hand side of the equation. So it's 1 over 2 du by dx, or equals u minus 1 all over u plus 1, plus 1 over 2. So we're going to have the LCD for these two expressions to just be, or we can say the first denominator is u minus 1 all over u plus 1. And then this is plus 1 over 2. So since the denominators are different and we want to make them, these two denominators to be the same, we can take this second denominator and rationalize it, 2 over 2. And take this first denominator and rationalize it on this side, u plus 1 over u plus 1. So now we're going to have 2 times u minus 1. That is, we just multiply. So it gives us, so this gives us 2u minus 2. And then next one, denominator now is just 2 times u plus 1. So we'll do the same on this side, u plus 1 all over 2 times u plus 1. So when the denominators are the same of a fraction, we can take one of them. So let's look at the next one, that is plus u plus 1. divided by 2 times u plus 1. So we have 1 over 2 du all over dx is now equal to 2u plus u is 3u, and then minus 2 plus 1 now is minus 1 all over 2 times u plus 1. Let's get rid of this. So we can now cross multiply. Cross multiply. So what do we have? We have 1 du times this. So this gives us 2 times u plus 1 du all equals to 3 times is to 2 times 3u minus 1 dx. Now, because this is x, we only need x expression here. So because it is not x, we have to get rid of it. So we divide both sides by 3u minus 1, divide this side by 3u minus 1. So 3u minus 1 cancel. Now we have 2, we have 2. So we can divide both sides by 2. So 2 and 2 will just go out. So what we're left with is u plus 1 all over 3u minus 1 du all equals to dx. Now we can integrate both sides to find our general solution. So let's erase this side to get enough space. So what we can do, we can separate the numerator expression. So we separate the numerator terms. So we have the integral of u all over 3u minus 1, right? And then plus the integral of 1 all over 3u minus 1 du all equals the integral of the x is just x. Now, if you like, you can apply long division because the power in the numerator is the same as the power in the denominator. You can apply long division, but we just want to apply some tricks. So the coefficient of this u is 3, so we can make this one to be 3. So because we put 3 here, we can bring 3 in the denominator. That is, we rationalize 3. The next thing we need to do is we can add minus 1 and subtract minus 1. So we have 1 over 3, the integral of 3u minus 1 to get the same thing down here, and we say plus 1. So it's just the same as 3u divided by 3u minus 1 du plus the integral of 1 all over 3u minus 1 du all equals to x. Now what do? We separate the first two terms from the last term. So we have 1 over 3, the integral of 3u minus 1 all over 3u minus 1 du plus the integral of 1 all over 3u minus 1 du plus the integral of 1 all over 3u minus 1 du is equal to x. So this and this is just equal to 1. Now for this portion, we can bring in some substitution. So we say let u, or let t now, equals to 3u minus 1. The reason is because the coefficient of this linear factor, this linear variable, which is u, the coefficient is greater than 1. So we want to get rid of this. We want to get rid of this 3, right? So we say let t equals to 3u minus 1. Because if you just say the ln of 3u minus 1, you'll be wrong. You must be able to indicate that there is a coefficient attached to this u that is not equal to 1. That's exactly our focus point. So we differentiate both sides. The t is just equal to 3 du. So if we like, since we have 3 du and we just have du here, we can just rationalize 3. So we say 3 and 1 over 3. No different, it's just the same thing. So anyway, we see 3 du, we're going to write the t. So we're going to do the same for this side. because the two expressions are the same. 3, 1 over 3. So take note that we also substituted t for 3u minus 1. So let's write it on this side. Okay. So now what do we have? We have 1 over 3, 1 over 3, the integral of just du plus 1 over 3, the integral of 3 du is just dt divided by t plus 1 over 3, the integral of dt divided by t, all equals to x. So we integrate now. So 1 over 3, the integral of du is just u plus 1 over 3 times 1 over 3 is 1 over 9. The integral of the t over t is just the ln of t plus 1 over 3. The t over t is the ln of t. Right? Great. So we have all equals to x plus some arbitrary constant c. So even if we want to consider, now this and this are the same, right? ln of t, ln of t. So we can just add their coefficients. So we have 1 over 3 u plus, so we add their coefficients, we have 1 over 9 plus 1 over 3, the ln of t. Or for short, you say since ln of t, ln of t, they are the same, we just factor it out and then we can add these numbers. All equals to x plus some arbitrary constant c. So the LCD here is 9. So this is 9. So we have 9 into 9, 1 times 1 is 1. 3 into 9, 3 times 1 is 3. So it's 3 plus 1 is 4. So this gives us 4 over 9. So this is 1 over 3. Now what is u? U initially was x plus 2y. And this is ln of t. Plus x plus some arbitrary constant c. So we can multiply. We have 1 over 3x plus 2 over 3y plus 4 over 9 ln of t plus, now this is equal, all equal to x plus some arbitrary constant c. So since we want to solve for this y, to further simplify the problem, we can send every expression on the right hand side of the equation. So we have 2 over 3y is equal to x. So we send this 1 over 3x, it becomes minus 1 over 3x. We send this one across, it becomes negative 4 over 9, the ln of t, and then plus some arbitrary constant c. So we can simplify this one. So 3 times x is 3x, 3x minus x. This gives us 2x over 3. So this entire expression will just be 2x over 3. So to get rid of this 2 over 3, we can multiply this entire expression with 3 over 2. So 3 over 2 times 2 over 3 is just y. 3 over 2 times 2 over 3 is just x. And then 3 over 2 times 4 over 9. So it's like 3 over 2 times 4 over 9. 2 here 1 times 2 here 2. 3 here 1 times 3 here 3. So it's 2 over 3. So this gives us 2 over 3, the ln of t, plus some arbitrary constant c. Now, if you like, you can still multiply the 2 over 3 by c, because 2 over 3 3 over 2 times c. This whole thing is still a constant, so we just replace it with some arbitrary constant c. So let's write it first so that you can see. So it's 3 over 2c. Now, what do we do next? What is t? T is 3u minus 1. So y equals to x minus 2 over 3 ln of 3u minus 1. That is 3u minus 1 plus 3 over 2c. We just represent it with some c. Again, what is u? U is x plus 2y. So x minus 2 over 3, the ln of 3 times x plus 2y minus 1 plus some arbitrary constant c. So there's a general solution for this differential equation. X plus 2y times dx minus dy equals to dx plus dy. So this is how we apply the reducible to variable separable method when considering this kind of differential equation. So thanks ever so much for watching, and see you in our next lecture. Thank you. Please subscribe to our channel. Thank you.